Hey, all right, so welcome to our 9th video. This is our last video on rational functions and polynomials. So today we're going to be talking specifically about features of the graphs of rational functions, in particular things called asymptotes, a strange word for what's actually a pretty simple thing. Here's a little mini agenda, and let's get started. Okay, so we talked last time about rational functions, what they look like in equation form, but when you're graphing rational functions, we find that they actually behave quite a bit differently than just regular polynomials. So what I have here is I've just taken two rational functions and I've graphed them using Desmos. So this is x minus 2 over x minus 3. So just remember from last time that a rational function is just a polynomial over another polynomial. So I plugged that into Desmos. And here's a different one, a little bit more complicated. Okay, now we're going to talk about this more formally in the next slide. But both of these graphs have things called asymptotes. And today's video is about being able to identify those asymptotes. So I say this again in the next slide, but an asymptote is just a straight line that the graph approaches. Okay, so I'm going to go ahead and draw the asymptotes in for these particular graphs because they're not too hard to spot. And I'll tell you a little about why those are asymptotes. Okay, so here we go. Okay, so these horizontal and vertical lines that I just drew are not actually a part of the graph itself, right? That's why I drew them as dotted lines. But what you hopefully will be able to see is that the actual graphs approach these lines. And when I say approach, I mean approach infinitely close. So on the left graph, that's not too hard to spot. This line, which is actually y equals 1, as we're going to find out, the graph is approaching it on both the left and the right sides. And this line, which is x equals 3, is being approached up here and down here. All right, now this graph is a little more complicated. It's got 3 different asymptotes, another horizontal one, and 2 vertical ones. And I just want to point out that I don't think it's by any means obvious that this one on the right is actually an asymptote because this graph is approaching this line, but it's approaching it really slowly. And in fact, you have to zoom up, or you have to scroll up on the actual graph quite far before you can tell that both of these blue curves are approaching this line, which is x equals 4. So sometimes graphs can be a little bit deceptive in that way, or you just have to scroll around. And if you like, you can plug these into Desmos yourself or plug in other rational functions and experiment around with these asymptotes and see if you can spot them yourself. It's a good exercise. So what I would say here is that there's 2 asymptotes, one vertical and one horizontal. And on the graph on the right, there's 2 vertical asymptotes and 1 horizontal asymptote. But let's be a little bit more precise about that. Okay, so what is an asymptote? Okay, an asymptote of a graph is a line, and by that I mean a straight line, that the graph approaches. I'm putting that in quotation marks because that, what I mean by that is a little bit easier to describe visually than it is in words. But if I want to be a little bit more precise, I can say that it's a line that the graph gets infinitely close to. So it keeps getting closer and closer to that line, but it may never actually touch it. In fact, it probably doesn't actually touch it. Okay, So there's two kind of asymptotes that we're going to be talking about today, and they're horizontal asymptotes and vertical asymptote. And all that word describes, horizontal or vertical, is whether I'm talking about a horizontal or a vertical line. So what is a vertical asymptote? It is an asymptote that is a vertical line. That's it. How do we describe vertical lines? Well, every vertical line, if you remember from algebra class, can be described as x equals some number because it's the x that's being fixed to give us the up and down line. So when you're describing vertical asymptotes, that's the equation that I'd like you to give at the very end. In this slide and the next slide, I'm going to talk about how using just the equation or just the formula for the function, we can find the vertical and horizontal asymptotes without actually looking at the graph. But the graph is going to be a good way to check those. So how do we find vertical asymptotes without graphing? Okay, so again, we're just talking about rational functions today. So everything we see is going to be a rational function. So pretty simple process for vertical asymptotes. First, we have to factor both the top and the bottom, and then we have to simplify. Remember the last video, simplifying means canceling out those common factors that might appear. After you simplify, then we look at the denominator, and whatever the roots of the denominator are, the real roots, those are the vertical asymptotes, right? And remember that there might be complex roots for any polynomial, but a complex root does not show up on the graph at all, so it cannot be an asymptote. Okay, now this is a simple example, and we're going to do a couple more examples at the very end of this video too. I've already factored it out. There's nothing to simplify because there's no common factors here. So I look at the denominator and I see, okay, what are the roots? Well, the roots are x equals -3 and x equals 4. And I make sure to write those as equations, x equals -3 and x equals 4, and those are my vertical asymptotes. Okay, there is also a root of the numerator. That root is x equals 0, but I'm not looking at the numerator right now, just the denominator. Okay, so again, we'll see this a little bit later, and you'll see me actually doing an example out. But let's take a look at the next slide. Okay, what is a horizontal asymptote? Well, it's an asymptote that is a horizontal line. That's it. Okay, now on graphs of rational functions, or pretty much any graph, you spot the horizontal asymptotes by looking at the far right and the far left sides of the graph. So whatever's going on in the middle of the graph doesn't matter for a horizontal asymptote. The only way that you're going to approach a horizontal line in a graph is on the far ends, left and right. How do you write a horizontal asymptote? Well, how do you write a horizontal line? You write it as y equals something. Okay. So the process for finding a horizontal asymptote is not that difficult once you get the hang of it, but I strongly urge you to write down this criterion that I'm about to describe. And you'll probably want to refer to it a few times as you're doing practice problems until you get the hang of this. Because there's a little bit more to it. So there's really, the first thing you want to look for when you're looking for a horizontal asymptote is the degree of the top and the degree of the bottom, meaning the numerator and the denominator. So, and what you're looking for is how those degrees compare to each other. And that's what breaks down this 1, 2, 3. So, if the degree of the top is bigger than the degree of the bottom, then there's no horizontal asymptote at all. All right. And the way you can think about that is that as x gets really big, the top is getting so much bigger than the bottom that number, that quotient, is just going off to infinity. Or maybe it's going off to minus infinity. So it actually kind of looks like a little bit like a polynomial, the way that polynomials go up and down, up or down on their far ends. If the degree of the top equals the degree of the bottom, that's number 2, then there is going to be a horizontal asymptote. And the way we find that is to look at the leading coefficients of both top and bottom and take the leading coefficient of the top divided by the leading coefficient of the bottom. And you're going to see me do an example, a simple example of that on this slide for this particular function. Lastly, if the degree of the top is less than the degree of the bottom, then the horizontal asymptote is automatically 0. Okay, and one way you can think about that is that the denominator is getting much bigger than the numerator. And when you take a number and divide by something much bigger than it, you get something pretty close to 0. Okay, so that's the way we'll think about these things. And we'll talk more in class about how you can make sense of why this criterion is correct, because I think it is something you want to feel is right. You don't want to just treat this as purely a formula. Let's do this particular example first, and then, like I said, we'll get to 2 more examples on the next slide. So what am I looking for? I'm looking at both the top and bottom, in particular the degree. Okay, so what's the highest power of x on the top? Well, it's 1, because this x is really x to the 1. And the highest power below is also 1. So that means the degree of the top and the bottom are equal. So now I'm in number 2. And number 2 tells me to look at the leading coefficients. Well, the leading coefficient is 1. It's not showing up here, but if I see x, that's 1 times x. And down below, it's also 1. Okay, so I'm in a pretty simple case here. I have 1 divided by 1. 1 divided by 1 equals 1. And that's, in fact, what I'm getting here. And I make sure to put a y in front of that, because every horizontal asymptote is y equals something. So I'm going to do that little calculation again. What I just said in words, I'm also going to write down. And this might be how you would write it down on the problem. You're welcome to kind of copy my strategy here. Okay, so I look at here and here. I see the degree of the top equals the degree of the bottom. Okay, so then I look at the leading coefficients, and that's 1 over 1. So I take 1 over 1, that's 1, pretty simple calculation, and that's what tells me that my horizontal asymptote, which I just initial as HA, is y equals 1. That's my answer. And sure enough, if I look at the graph, I see right here at y equals 1 that the graph is approaching that line from both sides. Okay, and the nice thing about rational functions is if it's a horizontal asymptote on the left, it will also be the same horizontal asymptote on the right, and vice versa. So, important to note, you can only have at most one horizontal asymptote if you're a rational function. Okay, let's do 2 more examples. All right, so here I'm just giving you the function, and I didn't take that extra step of factoring and simplifying. And because I'm looking for both horizontal and vertical asymptotes, I will need to factor and simplify. So let me do that first, and then I'll come back. All right. So what we have here, we have x squared times x minus 2 up top. Down below, I can factor that, and I get x plus 4 times x minus 2. And what I can see is that I can simplify this. Okay, so what does that simplification tell me? After the simplification, what are the roots down below? Well, the only root that's left is x equals minus 4. So that's what's going to be my only vertical asymptote. The root here, x equals 2, that I canceled, that's not going to be a vertical asymptote. In fact, it's actually going to be a hole in the graph. Okay, what about horizontal asymptotes, well, I'm going to look at the degrees like I did in the last slide. And I'm going to go ahead and write that down. So, degree, so the degree equals 2, the degree equals 1, and that means that there's no horizontal asymptote. Okay, but as we just said, there is a vertical asymptote, and the vertical asymptote coming from here is x equals minus 4. Okay, so that's the final answer for that first one. And I'm going to go ahead and do the second one as well. Okay, so this equals 2x over x plus 3 times x plus 4. Nothing to simplify here because I don't see any common factors. So what is, let's take a look at degree. So the degree up top is 1, degree down below is 2. So you can look back at that criterion to remember what happens if the degree of the bottom is bigger than the degree of the top. That's rule number 3, and that says that the horizontal asymptote is 0. Okay, and the vertical asymptote, sorry, I forgot one of my own rules that I said earlier. Horizontal asymptote is y equals 0. Okay, vertical asymptotes, well, there's 2 of them. X equals minus 3 from this root, and from this root, x equals minus 4. Okay, here we have it all together. Okay, so this video is getting a little bit long, but just to check this, I've actually graphed these down below. And what you can see here is that sure enough, there's our vertical asymptote at x equals minus 4. There's no horizontal asymptote. And notice that that's not a little smudge, that's a hole in the graph. Desmos doesn't know about holes in the graph, but remember that x equals 2 is not a part of the domain of this function because 0 over 0 doesn't make sense. And when I simplified it, I filled in that hole, but the original graph has the hole, and I should put it in if I want to make a complete graph of this function. Let's take a look at the second one real quick. X equals minus 3 and x equals minus 4 are the 2 vertical asymptotes. And sure enough, we also get a horizontal asymptote at y equals 0. Okay, thanks. I encourage you to try out the practice problems, and we'll do plenty more problems of this type in class. I will see you then.